All right. We're going to use this for a graph paper instead. Not that the old graph paper is bad, but some things are easier to graph on this. Some things are easier to graph on this. For example, if I'm talking about a radar, how does radar determine where a plane is, sir? Mr. Manship? I have radar, I've got a dish, I'm looking at a plane. How do I determine where the plane is?
Doesn't it just like find like the radio signal?
The radio signal. And hit the plane, it bounces back, and that tells me how far.
Yeah.
And the direction of my dish tells me which direction. So we're going to use that for this. We're going to say, okay, we're going to measure everything in how far and in what direction, rather than x and y components. Agreed?
Yeah.
Does that make sense, sort of?
Yeah.
All right, so now I'm going to look at this and go, the first point they want me to graph is 3 pi over 4. 3 pi over 4. So I'm going to graph a point 3 pi over 4. So I'm out 3, and my angle is pi over 4. Now, it's interesting is the way the components are written. 3 pi over 4 is backwards from the way I'm actually going to draw the thing. So I'm going to go pi over 4. This is 0. 0 radians, right? This is pi over 2. So pi over 4 would be right in the middle.
Yeah.
I'm going out 3 from the center. 1, 2, 3. That is my first point.
Okay.
It's my example point. So far, so good?
Yeah.
What if they asked me to do negative 2.5, negative 120 degrees? What would I do then?
You go down 2.5 rotations.
I'm agreeing with you there, sort of. But we always do this one first. Let's do that first. Yeah, so what's my angle going to be?
So
120 would be this way, right?
Yeah, right.
But negative 120 tells me to do what?
You just go the other way.
Go the other way 120 degrees, which is about like this somewhere.
Okay.
Right? And then how far do I go out?
2.5.
2.5, but it's negative 2.5. So what do we do whenever I see a negative? Do the opposite? What do you mean by that?
Instead of counting from the center, you go from outside.
The opposite goes to infinity, so that's not going to work. That's not a bad way to think about it. Instead of walking this way, I'm going to walk this way. Right? If this is the positive direction I'm walking, this would be the negative direction, correct?
Yeah.
So I'm going to go 2.5 this way, right to there. Is that okay? All right, with that in mind, and with these incredibly simple instructions that you can follow for certain, try to do problems 1 through 6 on the back. Go! Whee! 2 and 3 up there. Any questions on the rest of them, or you guys got it? Yes, ma'am.
I just have a question.
Let's do 4. 4 is pi over 4, so we go this way in general, right? To this line right here.
Yeah.
But it says minus 2, correct? So instead of walking this way, we're going to walk this way. Yes, ma'am? Sir?
Which one of those is number 2?
This is number 2.
Oh, no, okay.
Are we good?
Yeah.
Did I answer
So
your question
when
too?
yeah, I guess sort of.
Same as vectors before, right? If we get a negative, we just turn it around and go the other way.
So when the angle, or I guess the degrees is.
And the angle's negative, we go this way instead,
Yeah.
right? But we've always been doing that.
Yeah, I'm just saying that like when it just depends. No.
That is your Sussman.
Yeah.
How to graph y equals 2?
You go, yeah, you graph just a straight line on.
Like this, right?
Yeah.
Here's a question. How do you know that?
Can you plug in points?
I could plug in points. This is the game we played right at the beginning, right? Way back when. We said when x is this, y is this, correct? And you plugged in values of x, like let's say negative 2. When x is negative 2, what's y equal to? And then back then you panicked and the teacher laughed at you and said, this is silly, there is no x, so therefore y must be.
Oh, 0. Okay.
What?
Or nothing.
No. I put a negative 2 over there, see an x. You see the x's here?
No.
No, so what's y equal to?
It's only 2.
It's 2, okay. What if I put a negative 1 in there?
It's still going to be 2.
What about 0?
2.
What about 1?
Still going to be 2.
And then your teacher started drawing dots. 1, 2, 3. Oh, hey, what's the shape? You all celebrated good times, right?
Yeah.
All right. Try problem number 7. Go.
Completely guessing here. I went with, we don't know what our theta is going to be, what our degree is going to be.
So we're going to plug in a theta. What theta would you like to plug in?
I just said it would be anywhere on that line, so I'd say plug in, I don't know, 30.
30. They give us like radians though. So I'm going to be lazy and do pi 0, pi over 6, pi over 3. Is that okay with you?
Yeah, sure.
Pi over 2.
Because it's all going to be 3.
All of them are 3. All right. You're right. That's 3. Same drills we just demonstrated.
Exciting stuff. So then you're just going to put your circle around the third one out.
Circle?
You're,
Because this point here is here, this point's here, this point's here is here, that point's there.
none of those points are there. They're one more out.
Oh, no. That's bad. Don't do that. All right. Speaking for the class, I guess that works. Okay, let's do this. Doop, 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 right?
Yeah.
So this becomes a
Circle, a line.
circle, which is not shocking because what does r equals 3 literally say?
The radius.
The radius is 3. Draw the thing where the radius is 3. Draw all points that are 3 from the center. Those are both ways of saying draw a circle with a radius of 3. All right, everybody try 9. You might as well skip to 9 and then come back to 8. You could probably do 9 hopefully very fast and then come back to 8.
Are you for the table? You mean?
Yeah.
Do random r values.
Oh, right. So because it's theta equals, I might as well use r value. Give me an r value that's random.
1,
1, I love it.
2,
2,
3, 4.
3, 4. You happy with that?
Yeah.
Okay, I'm going to go ahead and graph that because you say I'm ready to go. These all be 60, right?
Yeah.
So we're in agreement. With me so far? So what do I graph?
Line.
Array or a line?
A segment.
Definitely not a segment.
Yeah, like a, I think that an arrow.
I think that's what I saw on your paper, did I not? And that's wrong. Why?
That'd be a segment.
So it's got to go up that way. It's got to go up that way.
No. Where would negative 1 be? Instead of walking this way, I'm going to walk that way, right? So it is a line, not a ray. Yeah? Does that make sense?
Yeah.
All right.
So it goes just up? No.
It goes both ways. Has to go that way as well, doesn't it? Because 60 degrees, if I put a negative 3 in there, 60 degrees, instead of walking this way, I could go 3 that way, put a dot, boom. Has to include those points. As funky as that sounds. So we're graphing lines on our polar coordinates by describing them as theta equals 60 degrees. That's starting to get weird. Under things you'll never use in real life. All right. On the front, it says the following. It says find the distance between P1 and 3 at 70 degrees and P2, 5 at 120 degrees. Now, a moment. There's a quick formula there. It says the distance formula for whatever. We're never going to use that formula because we know better. We've been doing trig for a while now. Let me first sketch this. Can I sketch this? Miss Krolik, how would this look? Where are those 2 points?
You go draw the circle graph, right?
Right, I'm gonna draw a circle graph.
Okay. So then you go up 3 and up to the 7.
So 3 this way at 70 degrees, agreed? Oh, 70 degrees would be down here. I probably should draw dashed lines. I was a little bit lazy there. Right, out 3. So this is my point, agreed?
Yeah.
And that's 70 degrees, and we're out 3. Everybody agree with it? Everybody see what I'm talking about? Okay. What about 5 at 120?
Up 5, up and up.
So I'm going to go 120 first, right? I'm going to find the angle.
And then,
That's out farther. It's at 5, agreed?
Yeah.
That's 120 degrees. I want to find this between those two points, right? So I want to find this distance here, correct?
yeah,
What shape have I drawn?
triangle.
Triangle. Is it a 90-degree triangle?
No. Yes.
Yes.
Yeah.
What?
I mean, no. Kinda.
I mean, it kind of looks like one, but I don't know. I'd
Yeah,
risk
yeah.
that. I'm thinking maybe not. It could be. Could be a 3, 4, 5. I don't know, but I'm thinking not. And if it turns out to be a 4, then I'll go, oh, silly, it was a 90-degree triangle. We could do this in 2 seconds. Because it's not necessarily, we're gonna note that this angle here would be what? That's 120. That's 70. What would this be?
Yeah.
50 degrees. That's for Krolik. Okay, so that's 50-degree angle, and we don't know it's not a right triangle, right?
Yeah.
So we can't use the law. We can't use our normal sine, cosine, tangent. We can go back old school, all the way back to chapter 3 and talk about the law of cosines and the law of sines. In this case, we're going to talk about the law of cosines. Why? Because I have this angle here, and I have the side opposite of it, correct? So the law of cosines comes into play. Law of cosines is a squared equals b plus c squared minus 2bc cosine of a. So on the formula sheet written just like that. I'm going to call this A, which makes this angle A, which makes this side B over here and side C over here. Agreed? Ms. Brazilian, you look like I'm not speaking good then. We good?
Yeah.
You just don't want to do it?
Yeah.
Oh, come on now. This will be fun. A squared equals, what's B? Squared. 5 squared?
Yeah.
Plus 3 squared. Minus 2 times 5 times 3 cosine. Now this is a little tricky because we got 50 degrees. Where do we get it from? We got it from 120 minus 70 degrees. You might say, Mr. Reddy, can I do 70 minus 120? The answer is yes, but cosine of negative 50 is the same as cosine of 50, so we don't care. That was a question you guys had, chapter 3, that I dodged. I said, don't do that. Don't do that. What are you doing? Don't do that. No, that's just bad. Why would you do negative angles? Ew. Doesn't matter, does it? If you go this way or that way, they're both positive. We're good. All right, here we go. A squared equals 2534 minus 30 cosine of 150 degrees. A squared equals 34 minus, I better slap this in my calculator. Oh, sorry, not 150, just 50 degrees, right? What is cosine of 50 degrees? Oh, I got a little tight. Oh, I got a better calculator here. On. Double checking my setup. I'm in degrees. That's good news. 30 cosine of 50. Boom. And this is 19.284. Remember, we're going to go 5 decimal places just to make sure you don't make a mistake. 34 minus that. I get a squared equals 14.716. I'm already rounding. I should say I should be able to round to the 0.5. I got a equals 3. What does it say to round to? Does it say anything? No. Hundredths, I guess, because it says hundredths. So 3.84 is my distance. So, law of cosines. We're to find this in 2 points of polar land. Okay? Yes, sir.
When you have cosine 120 minus 70 degrees,